Welcome back. This is going to be video 4 in our series of design and build a vacuum tube guitar amplifier from design to plug your guitar in it and rock it out. This is where we left off. So we figured out, looking at the wrong thing. We figured out that our PY 500A, which is this bad boy right here, we figured out that it's going to give us about 128 volts. And we also took a look at, I didn't call it this last time, but this is called ripple voltage. And we looked at peak to peak, and we made sure that it was less than 5% variation from the 128 rounded up here. And we figured out that it was 3.5, so we were good to go. Now let's make this into a schematic and figure out the rest of our power supply. First things first, you'll notice that this is 72.63 milliamps. And when we go here, we have 72.38. That's because I did not update this from when I designed the preamp. So I'm going to fix that now. That's going to be 72.63 because the preamp is going to draw 0.25 milliamps. How do I know? Because I know. And I will show you how I figured it out in the next video. All right, so let's change this too, because this is not 115. This is 128 volts that we figured out. 128. Look at us, precision. And we've actually got, just a quick refresher, we've got 115 volts measured from the plate to the cathode, and then we have an extra 13 volts from the cathode to ground because of the bias resistor. Then the cathode bias resistor is how we bias the tube and get our operating point. And altogether, from here to ground, we see 128 volts. So that's correct. Now we got to figure out in our next move how to come up with 115 volts DC. So I'm going to put this away, but before I do, I just want to point out that a quick review that our cathode is where we measure this 128 volts right here. That's where it comes out. And what we need to do is we need to make another stage. But once this right here, this 128 volts, once this is seen here in our next stage for this 115 volts, we only have 2.63 milliamps because 70 of our milliamps are being drawn by this plate. So I'm going to show you that. Let's get into her. So let's get our components first, and I'll show you what our power supply is going to look like. And the first thing we need is a transformer, because they are more than meets the eye. I said that joke last time, and it wasn't funny then either. Okay, part K1, we're just going to call this 120 volt AC. Okay, now I like to give myself a little bit of room to work, so I'm going to move this transformer down a little bit, and then we'll move as needed. The next thing we need our tube. So they don't have a PY 500A. So I'm just going to use a 5Y3 right here. Any rectifier tube will get you to this shape, and that's all we're looking for. And once we do that, we need the plate side, which is right here, to the transformer, and the cathode side out. So let's go ahead and use our handy dandy rotate tool, and then our flip tool. We got all kinds of tools. I'm going to double click this X1 and I'm going to call this PY500A. That's what it be. And I'm just going to put this right here. Now, the rest of our components that we know we need our first input capacitor, which we determined was this, 220 microfarads. So let's go ahead and make this 220 microfarad. Then we need to decouple. So what that means is we need the voltage coming out from that input cap is going to be different and out of phase of this next capacitor, which we don't know what the value is. Actually, we do. I'm going to tell you 22 microfarads, and I'll tell you why when we get there. Then we just need one more. I'm just going to eyeball it about there. 22 microfarad capacitor. Now we need some resistors, and this is what decouples. So we'll get into what our resistors are in just a second here. So just go ahead and in the value box here, just blank that out. So we need 2 resistors. And then go to your handy grabber tool thingy here. We got 1 resistor here. And I forgot to rotate this one. There we go. 1 resistor here. And right there. We'll bring this all together, maybe. Maybe I'll piecemeal it. Move over. There we go. All right, now it's all in position. So we know that coming out here, this is going to go to, now that I got this kind of roughed up, I'm going to bring it out this way. Move this. So we know, let's wire real quick, that coming up here to here is 128 volts DC. Now we got to get 115. So we need a voltage drop. And this is how we calculate it. So get your calculator out. And like I said, we dropped 70. Here, we'll go back to it. The 70 being drawn by the plate is being used up. So now we have 2.63 milliamps left going across this resistor. And we have 128 volts. We need that to drop to 115. So that is 13 volts. Now, the way to find out what our resistance is we divide our 13 volts here by our milliamps in amperes. So instead of 2.63, it's going to be divided by 1,000. So it's going to be 0.0263 amps. Because we divided 2.63 by 1,000 and that gets that. And, oh, I forgot to divide. Holy cow. What am I doing? So 13 volts divided by 0.00263 equals 4,942. That is our resistance. So volts divided by current or amps equals resistance. And that's what we're looking for. So now the closest value to 4,900 is 4,700. So we're just going to leave it 4.7K, which means the same thing as 4,700. And I'm going to move that above there so we know R2 is 4,700. And there's one more thing we got to do. So 4,700 times 0.00263, which is our amps. Now we're dividing our resistor by our amps to give us the actual voltage drop. So we're pretty close. 12 volts, 12.361. We'll just call it 12 volts. We also need to know how many watts this resistor is going to dissipate. And because when we buy a resistor, it comes power rated. So most of our resistors are going to be half watt, but we want this resistor to handle a little more heat than the rest of them. But let's see what the wattage is. So we just simply multiply that 12.361 times the current again. And yeah, 3/100ths of a watt. So in theory, we could totally use a half watt rectifier or 0.5 watt or a half watt resistor, not rectifier. But I like to use a 2 watt as a minimum, just because if that overheats even a little bit and runs away, it's going to burn up and it's going to destroy stuff, which is not fun. And I've had it happen to me before when I thought I was in a really good operating range, and it still burned up. So let's go back in here and make this 4.7K 2 watts. That way we know we need 2 watts there. All right. Now our last resistor here. We should connect this before we move on to the next resistor. We know we've got about 115 volts here. Oh. And I'm going to do this. And then do this. My fancy wiring job. There we go. And I'm also going to put right here 2.63 milliamps. Just in case I need to go back and figure stuff out, I know that I have 2.63 milliamps going here and 72.63 going here. And right here, we only have 0.25, which I will show in our next video how I determine that with our 2-stage preamp. So as far as this resistor here, we really just need to decouple it. And that's what this resistor and capacitor have done from here. So this 120 volts is out of phase from this 115 volts. And then we want one more phase right here. But what we want to do is we want to have enough resistance to, I'm not going to call it 1,000. I'm going to call it 1K. So R1 is going to be a 1K, this resistor here, and that is going to have text here 0.25 milliamps. And it's going to be about 115 volts. And this is going to have way less watts than this as far as power rating. But let's do the math on that real quick. Let's see what the drop is with 1,000 ohms of resistance and 25 or 0.25 milliamps, and then we'll figure out the power from there. So once again, we have 1,000 times. Now this is 0.25, so it's going to be 3 zeros and a 25, because we divide 0.25 milliamps by 1,000 to get to amperes. So we have a voltage drop of 0.25 volts. And if we multiply that by our amperes, 3 zeros and a 25, we come to, we're dissipating hardly anything. So this is what I'm going to say about this. We don't have to worry about it. It'll just be a normal half-watt resistor, just like this one. So really this resistor, and when we do the heater current, or heater circuit, you'll see we'll use another, maybe a 20-watt resistor. But other than that, all our other resistors we're going to use are just going to be at 5 watt or half watt, 0.5. So let's close this up. And then let's add some stuff. So in order for this to be legit, we need a switch. An on-off switch is just a single pole, single throw. Right here. Here we go. And this is where the plug from the wall is going to come in and feed into this transformer here. And it's all AC on this side, and then it becomes DC starting right here. So then the next thing we need is a fuse, but they do not have a fuse here, so I'm just going to write fuse for now. In another video, I will show you how to figure out what size fuse we need to run this circuit, and then that'll be the end of it. Okay, so just to recap, this is our power output stage. We have an acceptable amount of ripple voltage or ripple current here that we figured out from our power supply. Our total milliamps are 72.63 milliamps, and everything is setting up pretty good right here. It looks good to me. The only thing I'm going to do is I'm going to move this PY500 over a little bit so we don't get confused with what would be a better place for this. There we go. Looks a little scrunched, but it'll be all right. Okay, and that is it. Thanks for watching my short little video on how we do the power supply. If you have questions, please ask. I will answer them. As you know, I am just taking you through the process of how I do things, and we're getting through it. I know it's kind of quick, but I don't want to get into the weeds of things. There is a formula for figuring out this resistor capacitance pairing here, and it is to figure out ripple current. And it's a pretty big formula. It's not terrible, but you'll find that in the end, you're going to be selecting either a 22 microfarad or an 8 microfarad or 10 or a 20. Somewhere in that neighborhood. 22 microfarads is the most common. They're cheap. They work. I can't tell the difference between the sound of a 10 microfarad and a 22 microfarad by ear and a little amp. Some of the larger amps you'll be able to tell, and then it'll matter. But here, not so much. So I hope you got a lot out of this, and I'll see you on the next video. Thank you very much, and have a great day.